All right. Everyone good? Appreciate it. So this is track one, Invoke obfuscation, PowerShell obfuscation techniques, and how to try to detect them. A little bit about me. This is actually what I normally look like. My razor died last month, and I figured I'd just get a jump start. No Shave November has a pretty brutal competition in my office. I feel like I'm doing all right there. Say it again? Daniel H. Bohannon. So yeah, I'm an IR consultant with Mandiant. Been there for a little over a year. Prior to that, I spent 5 years doing IT operations and security for a national restaurant franchise. And I am a blue teamer. A lot of people will say this is a red team tool, semantics, but we'll get to that in just a bit. I'm going to be talking extremely fast because there is a lot of content I feel is necessary to make the full scope of the tool make sense and all the aspects of it and why I put so much into it. So there's not going to be a lot of memes. There's a couple at the end, so something to look forward to, but hang on tight and we'll get through this, and I'll post the slides afterwards and we'll be good to go. So quick outline, motivation, why have I spent the past year obsessing over PowerShell and over obfuscation techniques and semantics with PowerShell, and why should we care? This is DerbyCon, I don't think we need to say why we should care about PowerShell. It's absolutely incredible. Preparing your environment for investigating PowerShell, much easier said than done. I'll just briefly touch on that. And then we're going to look at an example of obfuscating the most common syntax you see for remote download Cradle, just to show syntactically how you can start obfuscating different tokens of a PowerShell command. Then we'll look at more methods for remote download. After that, we'll look at some more obfuscation techniques and how we can try to detect the second layer of obfuscation as well as the third layer, which will then take a dive into a couple encoding, decoding techniques, some that are common, some that I've never seen before personally in the wild. And then we'll look at what I like to call launch techniques, and hopefully you'll find this all interesting and the demo will be worth it. So, motivation, again, this is DerbyCon. PowerShell is being used all over the place. It's hard to think of an investigation where we don't see PowerShell being used at some point in the life cycle. Being used by script kiddies, attackers, pen testers alike. It's launched from all different places. Sometimes you'll see it stored in registry, kicked off as a service, file, macro, remotely. At the end of the day, we as defenders could think, well, we can just make sure we're looking for evil strings or potentially malicious strings in PowerShell's command line arguments, right? We'll get there. So, current state of detection. These two examples here, encoded command and this remote download Cradle, is typically what we see in a lot of investigations. However, for each of these, this is not the only way to write this exact function, and the PowerShell language is just so fantastically rich. There are so many ways that you can accomplish the same task with different syntax.
Sorry, is there a way to turn off the blank?
I'm not sure. What I basically did is took these two examples, encoding as well as the remote download Cradle, and started to think, okay, I'm not a red teamer, but what are all the different ways you can accomplish this task through different syntax? So, for example, if I have triggers looking for these particular syntax, these strings, then what are other ways that I could use as a red teamer to accomplish this task, but would get by my current detection? So I kind of played with myself. I went back and forth between red and blue team to kind of build out this repertoire of syntax as well as detection to take that into account. And as I began to discover new techniques, I would add that into our investigations, and actually started to find a handful of these being used by attackers. However, a lot of them have not seen it yet, but I'm absolutely convinced they're out there and likely being used. So my goal for the blue team, awareness. Knowledge is key. We have to know what's being used out there, and beyond that, what's possible, so that we can go ahead and be looking for that before we actually see attackers using it. The red team, hopefully this will assist you in evading detection so that you can test the blue team at the end of the day. Just like Carlos Perez talked about, the symbiotic relationship between red team and blue team, hopefully this will help both the red team and blue team test themselves to make an organization better. And at the end of this, there will be the public release of Invoke-Obfuscation to make the employment of these techniques simple, so that everyone can go home and actually test these techniques against themselves to see, did we actually detect this? Because at the end of the day, attackers are already obfuscating. We have to prepare ourselves for it. So this is hilarious because I include one slide on preparing your environment, which is probably the hardest thing in this whole talk. But that's another talk. People have already covered this very well. Logs. We have to be looking at we have to be looking at command line arguments for more than just PowerShell. We'll get to that. But at the end of the day, whether it's your 4688s with command line argument logs enabled, or sysmon EID1, we have to be getting those. If you have other agents that can do real-time process monitoring, then that's great as well. Or even something like Uproot IDS, open source, absolutely great. And then PowerShell module script block and transcription logging. If you haven't read this blog post with my colleague Matt Dunwoody, it's an excellent overview of each of these and kind of the before and after of what value it actually gives you. And I really do hope at the end of this talk that you'll see how just tremendously beneficial having those logs are to unwrap almost every single layer of obfuscation that we'll look at. So let's go through an example. This is the most standard remote download cradle syntax that we see, and it's generated by a lot of the big name tools out there: Veil, PowerSploit, Metasploit. So let's go through a little example. You have your attacker command on the top. We as defenders, how can we build kind of a signature to trigger on this activity? Well, we could say, okay, if we see invoke expression and new object, system.net.webclient, and download string HTTP, this would catch this command, right? We're all good there? All right, so let's start breaking assumptions. First of all, system dot is not necessary. It's automatically prepended. If you look at module logs, when you run this with a net.webclient, it'll automatically do a parameter binding of system.net.webclient. Not necessary. So as a defender, I'm not going to rely on system dot being there. I'm going to go ahead and pull it out. Next, the URL is a string. We can concatenate this string on the fly or set it as variables. With single quotes, double quotes, doesn't matter. We can add white space. Let's go ahead and get that out of there. Download string. Why could this be problematic? Net.webclient is a .NET class, and download string is a member of that class, but there are a lot of other members. A lot of commodity malware we see using download file, which brings it down to disk, but people typically use download string because it keeps it in memory. Download data also does the same thing, just as a byte array, as a byte stream, so you have to basically convert it out of that. But we have actually seen attackers using this once or twice. So why don't we just say .download as our indicator here? So we can't rely on there being a parenthesis here because you can actually set new object into that web client as a variable, and typically you'll see some tools do this and call the variable WC. So let's just remove that parenthesis off of there. .download. How could the dot be problematic? Well, because I'm OCD and very stubborn and bang away at the keyboard when I'm trying to figure out there has to be weird ways I can mess with this command, I actually realized that with the member argument you can actually throw single quotes around it. So now the dot is not reliable. Download now becomes a little bit less of an appealing string to add in there. But then I realized you could also throw double quotes. And the next slide, I want you to look carefully at download string, and I promise you this works, but watch. Add a tick mark. Why does this work? What is the tick mark? Well, it's the escape character for PowerShell. You can see there's 8 characters here, a 0, and then some lowercase letters. And typically you'll see the tick mark used for tick in for new line. However, you can add tick marks behind any letter that's not one of those characters, and you're good. So I got to think, well, this is pretty cool. So now we're just left with an N, an A, a T, R, and an M. What if I uppercase those? Yep, we're good. Tick marks every letter. So now this is actually what it looks like. The first picture up there is what it looks like in the command line arguments. The next picture is actually what it looks like in script block logging. So this actually persists all the way through to the deepest level of script block logging, as well as the concatenated string, the white space. So we can regex all the things, or maybe for now just scratch this as an indicator and see if we're okay with what's left. And actually, if you do decide to regex all the things, we talked about download string file data. There's also an open read, which also brings the payload down to memory, something else to keep in mind from a detection perspective. In addition, let's say you don't want to just do ticks. You want to treat a member argument as a string. You can encapsulate it with parentheses, concatenate it inline or as a variable, and then you can add a .invoke member operator on the end of that, and now it's a string. So are we okay to remove that as a solid indicator? Everyone tracking? All right. Net.webclient, this one's trivial. We can throw quotes around it and add ticks just like we did before. We can throw parentheses around it, concatenate it inline, or parentheses, or not parentheses, set it as chunk variables in whatever order we want. Executes perfectly fine. For this example, we'll just throw ticks. New object. So again, I mentioned earlier, PowerShell's language is extremely robust, and it's absolutely incredible when you're writing code. As a defender, when you're trying to nail down code, it is like nailing Jell-O to a tree. It is absolutely terrible, but it makes it fun and exciting. However, when I looked at this, I said, okay, well, new object doesn't have any aliases. Like, this should be pretty easy, right? Wrong. So PowerShell has so many commands, sometimes you forget which one you're looking for. So git command is there for you. So I can say, I know I have a command that starts with new-p something, so let me just add a wildcard at the end, and there's all the commands. Well, it's not returning text, it's returning PowerShell objects. So if we can specify the full command and return it, it's actually an object that we can invoke. We can invoke it with Invoke-Expression, or we can invoke it with the ampersand or .invoke operator. Now here's where it gets fun. Wildcards. That returns a single new object. That returns a single one. This. So this is new object now. Again, this is what it looks like on the command line. Module logs catch this. It does catch the parameter binding, but again, the evidence is all there, but it's in different places. And git command has an alias of GCM. And in addition, command. Now, why does command work for git command? In PowerShell, when you type a commandlet, it'll automatically prepend git dash to see if the commandlet exists. Awesome, right? I will tell you, as a defender, if you start keying on command being there, take into account there is a dash command argument. I've learned from experience. So yeah, prepend in the git, awesome, so flexible. At the very end, we can also, instead of using splats, or instead of using asterisk, we can set it in a variable as a string, throw it in there, good to go. So much fun, right? So much flexibility. In addition, PowerShell 1.0 syntax. PowerShell 1.0 has some gems. You just have to go and dig through posh code to find it. Execution context.invoke-command.get command get commandlet will let you do the same thing. If you want to use wildcards, you can do get commands, get commandlets, or you can do a combination of get command name, or get commandlets, or get commandlet, get command name. So just add those to the list. All right, let's just choose this one for the sake of simplicity, right? So now, you can do the same thing with get alias gal or alias, although you're not dealing with a full command name, you're just dealing with the alias name. So something else to keep in mind. In addition, we could have just thrown ticks in there. Get command is a commandlet, so we'll just throw ticks in that one. In addition, you can do splatting, so now you can treat the commandlet name as a string and concatenate it in line. So, do we want to regex all the things or just give up on this one? We'll see. So we're left with that, which is actually a really good indicator in and of itself, IEX or invoke command. But let's just mess with it. What's problematic with this? Well, again, we have the alias of IEX. Order doesn't matter. You can have IEX at the beginning or pipe the contents into IEX. You can throw ticks in it just like any other commandlet. You can do splatting just like any other commandlet. Then you have this thing called invoke command. Now, typically you see invoke command used to run a process on a remote system. However, if you don't specify a remote system, it runs on your system. So what's the difference? Invoke-Expression invokes an expression. We look at it like a string, right? Invoke command will execute a script block. And it is also quite robust. You have invoke command, ICM, you have .invoke parentheses, and you also have the dot and ampersand invoke operators. So let's add this to our list of Invoke-Expression. PowerShell 1's coming back with another hit. Execution context invoke script will handle an expression or a script block. So make sure you add that one to the list. So let's add in ticks there. Now, if you are dealing with an ampersand or a period, how are you going to make that an indicator? Well, if we're dealing with script blocks, we can assume that there's always going to be curly braces for a script block, right? No? No one wants to make that assumption? All right. Catching on. Because we can convert expressions to script blocks. We can do that with a .NET script block create, or we can do it with PowerShell 1.0, back to the rescue, invoke command.new script block. And for each of these, you can obfuscate them. And at the end of the day, the entire command that we worked to obfuscate up to this point is now a string. So now we can step back one more layer and say, now we can obfuscate all the commandlet stuff that we did. We can pull that out, treat it as a string, and now obfuscate it at a string level. That's layer 2. Same thing with .NET functions. I used to think these were a bit more immutable. Nope. Got a lot of fun there. I'll leave that to you to go back to the slides and check that out. So we'll go with the 1.0 syntax. So, fun? Good? This is where I propose the shift to looking for not only known bad, but indicators of obfuscation. For example, how often would you expect to see that many tick marks in a command? Not really. Eric Conrad yesterday at the Deep Blue CLI had an excellent approach. I tweeted out a screenshot of one of the obfuscated commands last week, and it happened to have like 25 plus signs in it. And what he did is he did a before and after analysis. He took the command and then removed the plus signs and looked if there was a difference in length to see that it decreased by at least 25. If so, you had 25 pluses, and that was an absolutely brilliant approach. So you can start to do that kind of analysis on certain characters that you typically wouldn't expect to see there, because a regex could kind of suck with this if you're trying to look for 25 instances of that character. So that was obfuscating the tokens, the actual elements of the language itself, and that was just for one example of remote download. Let's go back and look at the language and see what other ways can we actually do remote download. Well, we just talked about net.web client. If you have PowerShell 3 or later, you have invoke web request. You also have invoke rest method. With .NET, you have these four, and again, system.redundant. So let's go ahead and pull that out. There you go. Here's an example of doing that. Basically, when you use the .NET method, you have to get the response stream, get the response, close it, and then invoke it. So let's say that as a defender, you're monitoring anytime PowerShell makes a network connection. Well, can you have PowerShell rely on something else to go do its dirty work for it and then come back and get the contents? So what about Notepad? If we open Notepad, go to open, and instead of a file, type in the URL, what happens? Notepad retrieves our contents for us. So how can we have PowerShell interact with another application? Send keys. So this example, PowerShell creates a COM object, a WScript shell, launches Notepad, says, you're now my active screen. Let me send a Control-O to open. Let me then send the keys to type in the URL. Let me wait a second for the payload to come down. Let me send a Control-A to select all, Control-C to copy all, and the rest of the command is ripping it out of the clipboard and executing it. PowerShell never made a network connection. And at the end of the day, as a red teamer, whenever PowerShell makes something easier for you, it's usually to get better visibility. So for most things that PowerShell makes easy, .NET is really what's happening under the hood. So for every step of what we just did, there is the .NET version of doing it. And if you add a void in front of it, it is nearly silent in the logs. So anything with an open file GUI, you can do this with. I have POCs for Notepad, WordPad, Winword, Excel, PowerShell, ISE. Not as clean as you may expect. ISE is funny because you can just pull the payload down, then send an F5 and it runs. However, as defenders, this actually does hit disk in temporary internet files. So if you ever see .ps1s, or again, whatever the file name is, some of these actually maintain the file name, others create a random name, Excel creates a random name, but it will pull down at least one or two files that do remain on disk. So something to look for from a Yara or IOC perspective, you may find PowerShell scripts there. So send keys is kind of fun, but really sloppy. I mean, users would probably notice if Notepad starts flying up and downloading Mimikatz, right? So there has to be a cleaner way, and there is. So PowerShell COM object, instead of starting to spawn additional applications to the user, can actually do things like use Internet Explorer. Tell Internet Explorer, hey, you go fetch this payload. I'm going to wait until you're done, and then I'm going to query out whatever piece of the HTML I want that is my payload, and then execute it. What's nice about this is that it's cleaner. Nothing hits disk. It blends in with regular user activity because IE is making the connection, and it uses the user agent, the default user agent for that system. So, more obfuscation techniques. So remember we looked at the PowerShell 1.0 syntax where it took the entire command, treated it as a string, and then did string concatenation and things like that, right? Well, what other string concatenation techniques can we do? Well, we can reverse the string. We can do that by traversing it in reverse or casting it to a char array and then basically calling the reverse function, or using the .NET regex right to left. So that way, what actually is hitting the command line is the entire command in reverse. We can split the string, basically insert garbage delimiters and then split on that delimiter, piece it back together, and invoke it. Similarly, we can put in garbage delimiters and use split, whether it's the PowerShell split, .NET's, or the PowerShell replace, or .NET's replace. And keep in mind, there's a C replace and a replace. Keep that. And actually, the F format operator is absolutely amazing for a lot of really fascinating things. I'll touch on that when we get to the demo. We can also just concatenate strings through any of the join functions with PowerShell or .NET, concat, or even the plus operator, or just throw quotes around it and no pluses at all. So how in the world can we detect some of these string level techniques? Again, keep in mind, this is what would appear on the command line. If you have script block logging enabled, you'll see the layer 2 kind of obfuscation of the string, but it will automatically then, the next log, show you all this crap removed. So it'll get down to that base that base layer, which will still have the tick marks and that base layer obfuscation, but no matter how many times you wrap it with string and encoding or encrypting or anything like that, script block logging peels back the onion every step of the way. And for what's finally executed, module logging has the true parameter bindings. So again, those two together make most of the techniques I'm talking about. I'm not going to say it makes it easy, but it unravels a lot of the noise. So if you're only relying on command line, it's going to be a really, really difficult thing. So we can look for the presence of some of these reverse split, replace, concat, F format operator. However, they're not as uncommon as you may think. So this really comes down to you and your environment, how varied it is, how much capacity you have to look through all this stuff and weed out the noise. For us, since the detection mechanisms that we put into place has to scale to all of our clients, it becomes a bit trickier for us. But again, you can start to look for these operators. You can look for high counts of certain characters, like how many dollar signs would you expect to see if you're using variables to chop up the command, or how many times would you see, or how many semicolons would you see if you're doing a lot of commands in a row on a single command line, or pluses for concatenating strings. Well, keep in mind there's always a way to do it differently. You can actually use set variable and variable to get around that, and if you actually tokenize it, it won't even detect a variable, because it's basically looking at a commandlet and an argument going into it, not the variable itself. The same way you can execute multiple commands without semicolons, and you can concatenate without pluses. And if there's ever any character you can't figure out how to do a different way, just encode it with ASCII, and then the final command, that string char 59 is your semicolon. So you're good to go. In addition, type. This is the one piece that I actually removed from my tool. So Invoke-Obfuscation is compatible with PowerShell 2 and later. There's a slight difference in how you can obfuscate type tokens. As you see here in PowerShell 2, you can put ticks in it, but you can't introduce white space inside the square brackets or after the colon. In 3 and later, you can, and you can actually start to inject, you can start to basically put inline PowerShell comments. So now you can't even rely on a regex that says convert followed by infinite white space followed by square brackets. You can literally have any character under the sun in there. But stepping back and looking at it from indicators of obfuscation, how often would you expect to see an inline comment in the PowerShell command line? Something to look for. So, encoding, decoding. What are hackers actually using to obfuscate their PowerShell activity? Well, for the most part, they're just using encoded command because PowerShell gives it to them. And they don't have to specify an IEX or an invoke expression that's automatically implied. So we see this in a lot of places, as well as these flags. Typically, a lot of the tools will generate payloads with the shortest possible flag to save space. If you don't have any indicators based on the ordering and spacing of these flags, you're missing out on some low-hanging fruit. So these are typically what we see, like W, win, window for window style, EP, execution policy, bypass, etc. In addition, a lot of these don't necessarily have to be present. We have seen a lot of commodity malware basically going and changing certain registry keys before, so they don't have to specify certain arguments on the command line. So let's look at encoded command. Typically, this is what we see, encoded command, encoded ENC, ECE. So if we had this as a trigger, would we be good? Would we catch every instance of encoded command? I'm not even talking about .NET, just the literally PowerShell's encoded command. So this is what PowerShell gives us. They give us the full encoded command, and they give us EC. And they also give us encoded command, co. Every single one of these works because it automatically auto-appends an asterisk to find, are you returning a single flag? So whenever you're writing a script and doing parameter binding, you can specify just enough of the flag to get you to where you need to go. That's why you have not, nani, and null that are short for no profile. So now if we want to say non-interactive, we can do anything from nani all the way up to non-interactive, and it works. My tool will take that into account, and automatically, whichever flags you choose, it'll randomize the order, randomize the spacing in between it, as well as randomize which substring of the shortest to the longest you can have. And the reason I do this is not just to be not just to be mean, but it's because it's possible, and attackers are likely already doing it. And we need to make sure we're not making bad assumptions as to what can appear on the command line, because we're going to miss really bad stuff. .NET also has base64 methods. You'll see Metasploit use this a lot. Sometimes you'll see the .NET base64 decoding method paired with a gzip. Sometimes you also see attackers actually using AES encryption library. So let's look at some different ways to encode. What about ASCII? What about octal, hex, binary, bitwise XOR? We're starting to see bitwise XOR a bit, but some of the others, again, if you don't have, there are some really nice indicators you can build off of base64, even on tools. I won't mention any names, but even on tools that even randomize the case, there are components of that tool that are predictable enough with characters that don't have upper and lower case that you can actually build indicators based off of that. Just keep in mind, with base64, you have to have 3 signatures for any one plain text stream because of how base64 works. So at the end of the day, if you have that, your signature is not going to work if it's with ASCII or these other encodings. So we can't become complacent. And when you look at the join and the bitwise XOR, you don't even need white space before and after that. So again, don't rely on there being white space. It doesn't have to be there. Join can actually be at the beginning of a command, not the end. Things to keep in mind. So how about something different for PowerShell? How does PowerShell handle passwords? Well, there's secure string, right? So with secure string, does anyone recognize this flag, read host, enter password? No? Oh, sorry, wait. As secure string, but you know that asterisk thing. So this is reading in interactively the password, and then we're converting it to a secure string, and now we have a secure string object. Now what if we convert it from a secure string? It is this plain text deal. And that 0, 1, basically the highlighted portion, this will always be the case when you are using secure string without defining a key. Because what is the key? The key is the user in the current system. To make it very difficult to be able to take that text and run it, or basically decrypt it and pull the password out on another system. There are ways of doing it. That's not for this talk. So what if we actually specify the key? Then we can generate something on our attacker system and execute it on the target system. So the key can be 16, 24, 32-bit, and there's a lot of different ways that you can express that key. Again, run my tool enough times and you'll see all the different ways that you can generate random keys, which the tool handles. So when you do that, what's the size restriction? 65,000 characters. We're DerbyCon. We feel good about our passwords. I've never felt 65,000 characters good about my password. Why is it so large? What if we put an entire script inside of a password object? So that's what I did. So now this is the command iex iwr url.content. And I just chose the random key 1 through 16. And as you'll see, whenever you specify a secure string object with a key, then it will start with 76492D, that highlighted portion. It's fun to create network signatures looking for these things flying across the wire, because you'll find a lot of things passing secure string objects around with their keys trailing right behind them. So on a target system, you then you basically send that big blob of data, and then this is one of the ways that you can basically unravel it and rip out of context the plain text password, which is our command, our script, what have you. There's actually 2 different ways within .NET that I found to do this, as well as in PowerShell, creating a password object and ripping out the credential. All 3 are built into the tool. Randomly choose one. There you go. However, if you are unsecure stringing a 65,000 character object, you will spike CPU and it will take a good 20 or 30 seconds. So if you have a large payload, what you can do is basically take it, chunk it into a lot of small random sized pieces, delimit it, throw it up, stage it somewhere, and then on the target, you basically remotely reach out, pull down that, split it on the delimiters, and for each piece, unsecure string it and build out your command until it's all the way done, and then invoke it and you're good. And it takes 1 to 2 seconds. So after I finished this POC, I was pretty happy about it. And then I was searching for something else on TechNet, and I found this article from 2010 that someone said, is there any obfuscator for PowerShell? And someone replied and said, I guess you could use secure string to store a script in it and then pull it out of context. And I was like, no! Not original, dang it. I was so upset. What is really original in this field, right? But anyways, I kind of felt like maybe it was original. So I went and talked to my boss, and I was like, hey, I still think it's a cool concept, but I feel like this guy deserves the credit for it, you know? And he said, bro, 0 upvotes. You're good, man. So, but in all seriousness, the guy who wrote that is just Carl, who is a rock star on TechNet. So kudos to him. But yeah, so nothing is truly new. So lastly, launch techniques. We've looked at obfuscating PowerShell commandlets syntactically. We've looked at the richness of the language to accomplish the same task with different commandlets and objects. Then we've said, okay, once you do that, we can step back and treat the whole thing as a string and do that kind of obfuscation. We can then also wrap in as many layers as we want of encoding or encrypting techniques. So now, how can we obfuscate or obscure with launching it? So, you're confident in your regex, you can catch all this stuff, right? We're applying this regex to the command line arguments for every time PowerShell runs. Are we good? No. For 2 reasons. One, that I'm just going to briefly touch on unmanaged PowerShell. Ben, Tan, and other folks have done a much better job explaining this. There's other resources to go look at that. At the end of the day, PowerShell.exe not running, but a binary calling system management automation.dll. Keep in mind that all of this is logged in PowerShell script lock and module logging unless you have version 2 still installed and version 2 is specified, in which case it will not be logged. Good reason to uninstall 2 once you have 5. But what we're going to talk about is convoluted launch techniques for PowerShell.exe. So we're not doing the unmanaged stuff, we're only looking at the executable. So PowerShell help, again, gives us a nice gold mine. Dash command, the nice highlighted portion there says if the command is dash, then it will receive the command as standard input. What does that mean? This is typically how we used to launch PowerShell commands, right? Command C PowerShell command. What if we do command and then echo the command and pipe it into PowerShell dash? It runs. We can also specify the input variable, which is the standard input, and specify an IEX, and that runs. Now what does this look like for the command line arguments? PowerShell dash, PowerShell IEX input. Where's the command? Parent process. Sysmon will pull this together for you in a single log, as will 4688, the later versions. But have you ever looked for PowerShell arguments in command? Or in any process other than PowerShell? Maybe something to start doing. Or at least become savvy with the context, or the syntax of basically PowerShell invoking from standard input. So another thing you can do is say, okay, well, why don't we look at command and look for pipes and carrots and these escape things. Also a good approach. But you can't even rely on anything in there being, any strings in there being pieced together. So for example, you can't just always rely on it being pipe PowerShell, because you can actually chop up PowerShell inside of the previous command and then spawn 3 in a row, and there you go. You can also set in an environment variable the command, and then have PowerShell just go and IEX it. And this is actually already out there in the wild with commodity malware. Copter does this. It has obfuscated JavaScript kicked off out in the registry from MSHTA. JavaScript runs, sets the PowerShell command into a process level environment variable, then spawns PowerShell to execute the contents out of the environment variable, and all you see is PowerShell IEX random environment variable name. And there's more than one way, of course, to retrieve the value of an environment variable. Here's the ways that I've found so far. I'll leave that in there for later reading. You can also use clip. You can basically have command echo the PowerShell command to clip, and then spawn a PowerShell process to rip whatever's in the clipboard out and execute it. And this actually spawns clip.exe, a separate process, so I don't know if you're looking for clip.exe running, but maybe interesting. So the parent process tells the story, right? So we're good. We have our indicators. We'll apply it whenever PowerShell.exe runs and whenever its parent runs. No, it's not right. So this is, again, the example we just looked at, echoing it into standard input so the parent process has the command. What if we introduced a third process in the mix and had command PowerShell? So in the first command we set it, second command we then echo it into PowerShell. Does this work? Well, it executes, but it's still in the parent process. And this really frustrated me at first. I was like, well, it shouldn't be, because it should be further back. And then I realized I need to escape that pipe so that it is escaped for the first command, but not for the second. So that way it breaks out of the second one and applies only the second one to PowerShell. And when you do that, it works. And you know, it's funny, when you actually start building a tool to apply what you've been researching, you learn a lot more about it that you didn't realize. And actually in the tool, you can actually have the parent process only be command/C and then a comment, or not a variable name. And whitespace actually isn't even necessary between /C and command and echo. So don't even rely on that. So here's just a little graph showing the structure of that previous command. So why don't we just say, okay, let's recursively, if we ever see PowerShell spawning something weird like executing standard input or an environment variable or something like that, why don't we walk all the way up the tree and look for the command? Not quite. There are ways where you can basically have two completely unrelated commands passing information back to each other. So let's say you start with a command, right? It sets your PowerShell command and then spawns another command. And even with a clipboard example, it will basically write it in the clip up here. And then this will spawn another command of PowerShell to say, hey, wherever the clipboard is, let me grab the contents and execute it. So now if you see PowerShell executing clipboard and recursively go all the way up, you'll never find the actual command. You can do the same thing with WMI. We actually have seen an attacker do this before, where they basically have one command that will basically set the PowerShell command into the ethers of the computer, and then a completely separate process to use WMI to query out the process information, split it, delimit it, decode it, and execute it. So beware of pipes. I told you there's a couple memes at the end, right? There we go. Beware of Flappy Bird, obviously, that's a given. You guys ready for a demo? Yes. All right. Disclaimer, please do not use this tool for evil. All right, so the code is live on GitHub as of about an hour before this talk. And so import module is what you do to get it up, and then Invoke-Obfuscation. I like ASCII art, animated in particular. So this is just showing an obfuscated command breaking down into the actual payload. So you can see we have a help menu here. And so what we're going to do is walk through this tutorial. Options in yellow basically take you to something else, and options in green obfuscate. So tutorial, first we need to load a script. So you can basically set script block, or you can set script path, and the path can be a local file or a URL. Both work. So let's go ahead and set our payload. All right, we successfully set it. So now let's look at the other options we have. Again, yellow options will take us to the navigation. Green actually apply obfuscation. And there are options there, token, string, encoding, and launcher. We have back, cd ... for navigating back in the menu, also home main to take to the beginning. So for a quick example, let's go into the encoding menu and then apply the option number 5, which will apply secure string obfuscation. So we'll type encoding. There are options. Again, green actually applies something to the command. So we'll type 5. There it is in secure string. Again, randomly chose a way to convert it from secure string, randomly chose a key syntax, and output it there. So we can run test or exec to run it locally on our system. You probably don't always want to do this, but just to, for examples to see, yeah, this still works. Show will show you information about the command and where it is now with the obfuscation. Copy your clip, copy it to the clipboard, out, copy it to the disk, reset or remove the obfuscation, and then help for any other needs. So here's show command. So we have our script block. It'll show you every obfuscation technique you've applied and the obfuscated command as well as the length, because you want to keep the length in mind depending on how you're going to launch it. So it works. So let us reset this and do a little more interesting example, which is the remote download cradle. And you'll notice in this example, I'm using a file on disk. That's because I trust the people in this room so little, I don't even want my demo reaching out to the internet. But it's using download string, so it works on local or URL. So there's our syntax. Let's go through token, and let's look at what tokens does this command actually have. And we've already kind of looked at this in the slides, but this is how the tool handles it. So string, the URL is a string, so we can concatenate it in line. We can always set it as a variable, but for the tool's sake, we'll just do a string concatenation. So hit 1. Now our URL is concatenated. So let's go back. Let's look at the next one, command. In this case, we have 2 commands. We have Invoke-Expression, and we have new object. So when we go into the command menu, we'll see that we have ticks or splatting as our obfuscation technique. Which one am I choosing? Which one? We'll go with 2. All right. I was going to ask the crowd, but it's pre-recorded. So now Invoke-Expression and new object both are splatted, and they randomly chose to use the dot as opposed to the ampersand. So net.webClient is an argument. So let's jump into the argument menu. For arguments, we have random case, ticks, concatenate. We'll go with ticks. Net.webClient, ticked up. Download string is a member, so we'll go into the member menu. Here we have random case, ticks, concatenation. We'll go with concatenation. Now, if you notice with this, when you concatenate it, remember you have to add a .invoke member. So sometimes certain obfuscation techniques will introduce one that you haven't covered before. So it's always nice to go back and run it 1 or 2 times to catch that. So we'll go back into the member obfuscation and rerun it to make sure we get that invoke so we don't leave anything untouched. So we'll do the tick obfuscation. Now invoke is obfuscated. So that's everything in the command from a token level. And this is using the .NET language parser to basically tokenize the command and figure out which piece is which. So I'll paste it into a PowerShell prompt, and as you can see, it works. Now, event logs. So let's look at this. In PowerShell, we look at the, that's a bit fuzzy, but when you look at the script block logging, the finally obfuscated command contains exactly what we saw in the tool. The payload that it invoked was not obfuscated, so it is there in plain text, but there's nothing from stopping you from obfuscating both the calling command and the payload itself. So let's remove the obfuscation, and at the end of the day, it's taking a lot of time to do all this, so why don't we just use the all and hit 1, and it'll go and randomize the order of which things it hits first and does it all for you, and you can run it as many times as you want. So let's go back to home. So the second thing we can look at is string layer. So we can basically take whatever command we currently have obfuscated, or not obfuscated, and we can reverse it. And again, it will choose one of those random reversed functions that you saw in the slides, and the whole command is in reverse. Still works. Good. So next, let's remove that. Let's look at the concatenate function. There you go. Again, randomly choose concatenate operations. Let's remove that. Let's look at reorder. This is using the F format operator and basically chops up the command, delimits it, and then reorders it using the format operator. And again, you can apply all these in a row and stack them on top of each other. And it gets messy, but it still works. Having fun? Good? All right. Encoding. So this is looking at those more obscure encoding techniques. I didn't include base 64 or straight up AES because people are already kind of using that. I wanted to include some more fun stuff. So ASCII, hex, octal, binary, secure string. Each works. There's octal. Let's test it. Yeah, we're good. Binary works. Secure string. Secure string grows rather rapidly, so use that one sparingly. And if you pop the 8,190 limit, it'll give you a warning that, hey, you may want to start over. You're trying to put this in a command prompt. So launcher, the last thing that we covered. Basically, how are you going to launch this sucker? So we have a standard PS and command, then we have environment variable standard input, and then we have var++ and standard input++. So for var, we basically have a command prompt that sets the PowerShell command, then spawns a child PowerShell process to invoke the contents of that process level environment variable. And again, it uses a lot of different techniques. Every technique that I've found so far to be able to extract the value of an environment variable, it randomizes between all of those, chooses it, and applies it each time you run it. Then you can choose whatever flags you want to do here, and it will basically take each flag, again, randomly choose the substring of that flag that works, randomize the order, randomize the white space between it, and there's your command. Once you apply a launcher, if you try to run tests, it'll basically say, hey, you can't do this in PowerShell because you've already wrapped it in something else, and I can't do any more obfuscation because it's no longer just a PowerShell command, but I've tried to make the interface as user-friendly as possible, so you'll get little prompts to be like, hey, like, you can't do what you're trying to do, reset obfuscation if you want to. And so you can basically see the command there, and again, the payload, basically the part of the command that's invoking the environment variable, the whole bottom two lines is obfuscated automatically for you. So let's copy it to clipboard and throw it into command.exe. Does it work? Yeah, it does. Okay, cool. There we go. Now, let's look at sysmon. And again, we've already kind of looked at this in the slides, but just showing you that it works. The PowerShell command is basically PowerShell followed by the random execution flags, followed by the syntax to invoke the environment variable, and then the parent process is the one that actually contains the PowerShell command. So let's go back and let us apply one of the plus++. So basically the plus+ is saying instead of pushing the command to the parent process, I want to push it to the grand. There's absolutely nothing stopping you from pushing it further. Just escaping becomes an absolute nightmare when you start to stack that many layers on top of one another. I figured 2 was enough to prove the point and to show it's possible, just to break habits of assuming it will be in PowerShell or the parent process. So in this case, we'll choose standard in ++. Again, choose whatever flags we want, and it will generate our payload. Go ahead and grab that. So again, it's us. Yep, we're going to grab the clipboard, throw it in. We're good. Let's check sysmon one more time. And again, we'd expect to see the PowerShell with its randomized flags, and then ending with just a single dash, which is the standard input it chose to use for this iteration. Again, randomly choosing between all the ones. And the parent process is literally command/C and then an environment variable name. And it's not even, if you're using the var++, it's not even the same environment variable that the PowerShell is calling. It's a variable that then calls the PowerShell command referencing another environment variable. It's kind of like Inception. So let's go to the grandparent process. That's where the command is actually stored. And we're basically going to do a rapid fire token all 1, 1. Let's do it again. Let's keep going. Let's go back. Let's throw in, since we've done token, let's go back to string. What are we going to do? We're going to do a reverse. Good. Let's go back. Let's go to encoding. Let's do hex. Hex encoded. Good. Test. It still works. Let's go to launcher. What do we want to do? Standard in ++. Launcher applied. Let's go ahead and get our flags. There we go. Copy it out to clipboard. Throw it into command. Does it work? Yes. So again, the tool even says, please obfuscate responsibly. So in all seriousness, what does this mean for the blue team? Well, as I kept finding more of these techniques, it was exhilarating, but honestly kind of frustrating. And I really like what Jeffrey Snover said in the keynote. Basically the difference between real security and hope fueled by ignorance. Again, I'm a blue teamer. My hope is that this presentation and this tool will shatter hope that current detection is sufficient and will get rid of us relying on an ignorance of what is syntactically and obfuscation-wise possible with PowerShell. This is honestly what I feel like a lot of the times when I see this stuff, and perhaps some of you feel this way as well. But at the end of the day, attackers are already obfuscating. We have not seen them obfuscate to this extent, but it is possible, and I'm absolutely positive that they are. Well, positive is a strong word. I feel pretty confident that there are people who are much smarter than me that have figured this out, that have been using it for quite a while. Let me put it to you that way. A purely command line argument approach will be absolutely difficult. If that is truly all you have to work with, then that is a shame, but there are things that you can do to counter that. Again, shifting from looking just for known bad to also looking for indicators of obfuscation, and being aware of these launching techniques to know where you're even looking for PowerShell in the first place. So what if we were dealing with obfuscation in Python or VBA? Like, would the logs be better there? Right. So again, people like to badmouth PowerShell. Look at these incredible logs that we have. Absolutely amazing. I also hope that if in your organization you've been pushing to get PowerShell 5 and the incredible logging that comes with it, if there's been pushback, may this tool help empower your cause to say, this is why we need this logging. That would make me immensely happy. If that actually happens and you do get that, then please tweet me. I would love to hear that. That would make me feel very happy. PowerShell script block logging simplifies every layer of the wrap obfuscation until you get down to the base layer. So if you are looking for these indicators directly in script block logging, you can disregard all of the string level encoding and launching techniques, even unmanaged PowerShell. Forget all that. You're getting the raw, the last thing that's being run, but you have to still take into account tick marks, string concatenation. Basically, the lowest level that you have that you're not invoking, you still have to take that into account. So keep that in mind. And lastly, break all assumptions of what you know. Again, are you absolutely positive there has to be a white space before this? If not, I wouldn't include it as an indicator. Know your options. Again, PowerShell is just my favorite language. I'm absolutely obsessed with PowerShell and the richness and the complexity of it. Or not, it isn't complex in and of itself, but when you try to start nailing it down, it becomes a complex animal, but it's absolutely exhilarating. Know what options exist so you can know how to defend against them. And finally, I can't stress enough, hunting for indicators of obfuscation. At the end of the day, when you start to generate all these payloads yourself, you'll start to see there are things in there that are really weird that shouldn't really exist there to the extent that they do. So that's my word of encouragement. Credit where credit is due. Just a lot of great people I get to work with on a daily basis, and some previous colleagues as well, helping me, just encouraging me to pursue this research. Again, this has been my life for the past year, hundreds of hours of research, over 300 hours of tool dev time, personal time in the past 2 months for this. And finally, and definitely not least, is my wife, Paige, for putting up with all this time I've done into this and encouraging me all throughout the way, and honestly, humoring me by listening to me talk about how amazing PowerShell is. So thank you very much. Any questions? Yes?
No, there's the script block logging and the transcription logging. How do you see that differ in its ability to expose some of what's happening there?
I would say use both and test this and see for yourself. There are ways to cause stuff not to appear in transcription logging. It all depends on what kind of payload you're trying to launch. So any one piece of evidence I would not rely entirely on, but together it really does paint the picture for you. Yep. Yeah, so the question is, what would we like to see Microsoft change with logging and behavior? They've kind of already done it. I mean, the logging is there. It's just a matter of not many people have it or are using it. And it can be a little tricky to figure out with so much data being there and depending on how you're ingesting the logs. But at the end of the day, I mean, Microsoft really has handed us a gift on a golden platter to have this kind of logging with scripting languages. Any thoughts and suggestions and questions that I've had about any of these techniques and ideas, they've been more than supportive and listened to and entertained those ideas. So if you have ideas or recommendations, I would say reach out to them. They're a great bunch of folks.
Thank you.
Absolutely. Any other questions? All right. Thank you very much.